Okay, I'm Ellen Jorgensen. Just briefly, I spent most of my career in the biotech industry before synthetic biology. And about 7 years ago, I segued into more science communication and outreach by co-founding Genspace, which is a community biolab in Brooklyn. So I was tasked with leading the discussion for the education working group. I think it's interesting that I think we were probably the smallest group, and I think that has something to do with the way the word education sounds to everyone. It's sort of something like that, sort of like eating your spinach, particularly to people who are active researchers. Getting involved in the education component often means dragging yourself out of the lab and having to teach a class that you don't really want to do, but you have to. So I think part of the education working group's mission is to make education a lot more fun and exciting so that more people will join the education working group. I owe a lot to Natalie Kuldell for these slide suggestions. She found, first I wanted to, all of these groups are going to overlap somewhat. We struggled a little with education versus communication. I'm going to show you sort of a spectrum. This is my take on it, not the group's, that in education the flow is more unidirectional, not entirely, because of course we learn by teaching, and that the idea is to teach in an accessible manner to try and get people to want to learn more, whereas communication is more of an equal flow of information back and forth. And the goal of that is often to convey an accurate view and to get people on board with the risk-benefit ratio associated with the technology. So that's certainly up for interpretation. But this figure from Morrow 2000 is interesting because it made me terrified because of the scope, the sheer scope of what education can mean. So we go in this diagram all the way from the sort of education that maybe you would think of, which is in usually a school or formal, to the informal that might be more, say, in a museum setting, to outreach, which could be really overlapping with the communications committee, where you're talking about popular books or movies. And it goes from kind of a deeper understanding being conveyed to something that is more very high level, just sometimes even just an awareness that the technology exists. The formal would take place in, say, a school. I think a really great example of this is the program that Jeff started at Johns Hopkins, where the students actually built a chromosome. And this would encompass things like university classes, even high school level classes, the content of textbooks, curricula, all of the formal education that we're used to. Then when you segue over to informal, there's a little space in between that can be things like science fairs or other public events that are put on by these institutions to convey the science. The informal is a museum or perhaps a community outreach program like Genspace had. So we had, for example, CRISPR workshops with the general public at Genspace, and museum programs like the one that Natalie was one of the PIs on with the Boston Museum of Science, called Building with Biology, was another really interesting program. This component of it took educators and in the museum outreach programs and put them together with scientists, and it came up with about a dozen different activities to do in a museum outreach session, sort of hands-on stuff or games that would teach the public about synthetic biology, but also these really interesting forums, which were very well thought out, where you were supposed to spend a couple of hours and people would get a scenario, and there were two of them. One was, should we engineer the mosquito, and the other was, should we edit the human genome? And it was like a case study. There was background, there were little cards that represented the stakeholders, It wasn't quite role-playing with people, but people got into seeing the points of view of all the different parties, and then there were questions that you had to answer, and there were no right answers. So, for example, we did the Should We Engineer Mosquito one. It was things like, well, who should make the decision about releasing the mosquitoes? Should it be the government? Should it be the villagers? Should it be an NGO? Should it be the United Nations? Things like that. And I think these exercises would be really interesting to do in the context of this particular effort. Then as we go more towards the sort of light experience, low contact time, you get things like Siddhartha Mukherjee's books, Emperor of All Maladies, The Gene, programs on Nova, popular science articles. NASA has an amazing website. If you've never been to any of the NASA websites, they have a website just for students and then a website that's a general website. Of course, they have all of that fabulous space imagery. But I was looking at some of the imagery of that image on the cover of Science of that chromosome that looked like a flower. There are things that would be very attractive to convey to the general public to get them excited about this stuff. So also bouncing off of this is kind of the marketing and the news media at the end of all of this, which is perhaps the largest audience of all. One thing that's interesting is if you look at what happened with synthetic biology, a whole field was essentially created through a competition that was very well publicized, had a lot of news media coverage, was at a prestigious institution, and involved the next generation of scientists. And because iGEM was so well crafted, I think that's really single-handedly the thing that started the field of synthetic biology really as a true educational discipline. And also in parallel to that was Natalie's Biobuilder program, which started as the course that she taught at MIT to undergraduates and then was adapted down to the high school and even pre-high school level in a series of lessons around synthetic biology. So a few random insights that we had at the table was that the concept that engineering is for discovery as well as product development. And if you can get some open questions to use in teaching, it's the most effective. Unfortunately, people tend to get their information about science mostly through movies and books, and that language is important. As I said, these are kind of random insights. There were some questions that we thought the committee would have to grapple with. First, what is the overarching thing that we want to teach? And I think this is a theme that's been resonating through all of these committees, is sort of what's the big message? And maybe it's the idea that a genome can be built at all. I doubt the general public, they might have some concept that genomes can be edited, but the fact that you can actually build one is probably new to most people on the street. And if you remember Leslie's slide, the difference between editing, where you just replace a word, and building, where you just rewrite the whole paragraph, that makes it really clear. And then how do we prioritize when you have this huge spectrum that you could be working on in education? Do we do it on the basis of what we can fund easily, what we can implement easily, what'll have the most impact? And then can we learn anything from previous large projects? And of course, how can we integrate with the other working groups, particularly the communications group, to deliver a coherent message? So join our committee. We probably should include all of these different types of people, and there are probably other people that we should include also. So I've been saw the little sign that said it's time for stop for questions. So if anyone from the committee has any more comments, or if anyone has any questions, I'd be happy to take them now.
At the Smithsonian. I think it opened at the Smithsonian, and it was on the Human Genome Project, and it basically explained the project to lay people in terms of the historical context. And then there were stations all around where people could go and they were asked genomic questions that would affect their family. And then they could put their answer in, and they immediately got a response back which told them, out of all the people that answered this question, 60% agreed with you or 60% disagreed with you, which actually helped them to put what they were learning into context, right, in terms of the larger community. And I believe that exhibit traveled around the country. I thought it was just one of the most really interesting and effective tools for education I had seen in terms of the public.
There's a huge, huge opportunity for amazing, amazing tools like that in museum kiosks and many other venues. You'd actually be surprised at some of the venues that science is getting taught at. Guerrilla science is running around Burning Man doing things. I mean, it's very interesting. We live in an age where there are many, many more opportunities for educating through all sorts of new roads.
Our early days at Genspace, actually, you had the FBI come to hang out in the lab just to make sure that everything was copacetic. Do you imagine having similar kinds of outreach for GP Wright, where we have maybe Comey is free, I think, now, so we could have. Yeah.
Well, I think that the FBI was interested more from the capability of the community labs to actualize the technology in a meaningful way. And also, of course, they've got this mission now. They show up at iGEM every year, and they essentially deputize everybody there with the sort of if you see something, say something idea. I actually don't think that this particular project is as frightening because it takes so much money and so much sophistication to do it at the moment. I don't think it's at the point where people are going to start worrying about amateurs doing it. Not for a long time. Participating in terms of, the usual kind of citizen science where you do a part of a project, but certainly not spearheading a genome build.
Or not a genome build, just more a genome edit, I think, but yeah.
Oh, yeah, well, I mean, we've already fended off a lot of reporters around CRISPR.
Yeah.
Maybe just to add to your comment over here. So the comment about it's so difficult and expensive, so therefore your average Joe off the street is not going to reproduce that. I don't think that's the issue that the FBI and some of those people have. The issue is more, once you've built it, how can you secure it? Can you make sure it doesn't escape? I think that's the bigger issue.
Well, most of these community labs, I'll just segue into that very, very briefly because I've got the end sign here. But if you want to discuss that further, I mean, we're all BSL-1. We don't handle pathogenic organisms. The same guys take away our waste that take away the university's waste. I mean, these labs have actually become fairly institutionalized, and I don't think that lone actors, with all the hoopla, you know how hard it is to get anything to work in a lab. I mean, really. Okay.